Hello student, in my previous video I had completed all practice set. Now in this video we will see the problem set 2. You will get the link of all videos if we click the I button of this video. Now let us start problem set 2. First example. Now choose the correct alternative answer for the questions given below. First, which one of the following is an irrational number? First is in root of 16 upon 25, B root 5, C 3 by 9 and D root of 196. And here the answer is B. Root 5 is an irrational number. Now how it is irrational number? We have the root of 16 upon 25, that is equals to 4 by 5, which is a rational number. Root of 196 is equals to 14. This is again a rational number. And again 3 by 9, this is also a rational number. Out of these only root 5 is only a rational number, and hence option B is correct here. Okay, except root 5, all other given numbers are rational numbers. Next, which of the following is an irrational number? First A is 0.17, B is 1.513 raised to bar, C is 0.27, 46 raised to bar, and D is 0.1010001000 dash dash. Okay. Now, in this case, the option D, that is a 0.1010001000. This is an irrational number. Numbers in option A, B, C are rational numbers. Okay. The given number, that is a 0.1010001000 is non-terminating, non-recurring number, and so it is an irrational number. Next, decimal expansion of which of the following is non-terminating recurring? Okay, now here the first option 2 by 5, B is 3 by 16, C is 3 by 11, and D is 137 upon 25. And here non-terminating recurring is 3 by 11, and hence option C is correct. And why it is correct? The denominator 11 does not have 2 or 5 as a prime factor. So 3 upon 11 is non-terminating recurring. Next, which of the following number is represented by every point on the number line? First, natural numbers, irrational numbers, C, irrational numbers, D, real numbers. And here the option D is correct here. Real numbers. Every point on the number line represents a real number. Now next, the number 0.4 is to dot in P upon Q form is, first option A is 4 by 9, B is 40 upon 9, C is 3.6 upon 9, D is 36 upon 9. And here option A is correct. Okay. Now how it is correct? See this here. Let x is equals to 0.444 dash dash. Next, multiply on both sides by 10. Then you will get here 10x is equals to, take this one decimal to the right. Then you will get here 4.444. Okay. Next, subtract x is equals to 0.444 from this equation. That is a 10x minus x is equals to 4.4 is to dot minus 0.4 is to dot, and hence their subtraction is a 10x minus x. You will get here 9x is equals to 4, and hence x is equals to 4 upon 9, and hence here option A is a correct. Now next, what is a root of n if n is not a perfect square number? Okay, first option is a natural number, a rational number, irrational numbers, and D, option A, B, C, all are correct. If n is not perfect square, then the root of n is irrational numbers. Okay, here option C is correct. If the number is not a perfect square, then its root is always an irrational number. Next, which of the following is not a surd? First option A is a root 7, B is cubic root of 17, C is cubic root of 64, D is root of 193. And here, if you observe this, the cubic root of 64 is equals to 4, which is a rational number, and hence cubic root of 64 is not a surd. Okay, option C is a correct here. That is cubic root of 64 is equals to 64 is to 1 by 3. But 64 means what? 4 is to 3. Whole bracket is to 1 by 3. 3 into 1 by 3, that get cancelled. And hence you will get here 4 is to 1, which is equals to 4. This is not an irrational numbers. And hence cubic root of 64 is not a surd. What is the order of the surd? That is a cubic root of root 5. First option A is a 3, B is 2, C is 6, D is 5. Now here the order of the surd is 6. Now how it is 6? See this here, option C is a correct here. Now cubic root of 5 can be written as root 5 raised to 1 by 3. But what about the root 5? 5 raised to 1 upon 2 and whole bracket is to 1 by 3. 1 upon 2 into 1 by 3, then you will get here 1 by 6, and that's equals to 6th root of 5. And hence, the order of the surd, that is the cubic root of 5, is 6. That is option C is correct. Next, which one is conjugate pair of 2 root 5 plus root 3? First option A is a minus 2 root 5 plus root 3. B is a minus 2 root 5 minus root 3. C is a 2 root 3 minus root 5. D is root 3 plus 2 root 5. And here the option A is correct. For the conjugate pair, here if we multiplied the 2 root 5 plus root 3 with minus 2 root 5 plus root 3, then you will get a rational number. Okay, now see this here, root 3 plus 2 root 5 into root 3 minus 2 root 5, and their product is, this is a plus b into a minus b of this form, that is root 3 bracket square minus 2 root 5 bracket square. Root 3 bracket square means what? 3, and 2 root 5 bracket square means what? 2 square is a 4, root 5 is a 5. That is a 4 into 5, 20. That is a 3 minus 20. You will get here minus 17, which is a rational number. And hence, conjugate pair of 2 root 5 plus 3 is minus 2 root 5 plus root 3. The value of modulus of 12 minus in bracket 13 plus 7 bracket complete into 4 is, now we'll simplify here, that is a minus, first option A is a minus 68, B is a 68, C is minus 32, and D is 32. Okay, here option B is a correct here. Now how it is correct? See this here. Modulus of 12 minus in bracket 13 plus 7 bracket complete into 4 is equals to, okay, that is a 12 minus 13 plus 7, you will get here 20 into 4. Then you will get here modulus of 12 minus 18, and that is equals to modulus of minus 68, and hence overall you will get here 68, and hence option B is correct. Next, write the following numbers in P upon Q form. These are the examples. Now we'll solve one by one. First example, 0.5555 dash dash dash. Now the solution, 0.555 dash dash, that's equals to 0.5 raised to dot. Let x is equals to 0.5 raised to dot. This is the first equation. Next, here 5 is only a recurring digit. So multiply both the sides by 10. Okay. And hence, here you will get here 10 into x, that is a 10x. Now this 5 raised to dot means what? 555. If you multiplied to this number 0.555, then you will get here 5.5555, and it is written as 5 raised to dot. Therefore 10x is equals to 5.5 raised to dot. This is expression number 2. Now the subtraction. Subtract x is equals to 0.5 raised to dot from this equation, that is a 10x is equals to 5.5 raised to dot. 10x minus x, you will get here 9x, and 5.5 raised to dot minus 0.5 raised to dot, you will get 10x minus x, you will get here 9x, and 5.5 raised to dot minus 0.5 raised to dot, you will get here 5, and hence here x is equals to 5 by 9, and hence the number in P upon Q form is 5 by 9. Okay. Now next. Again, write this number 29.568 raised to bar. Let x is equals to 29.568 raised to bar. Here 5, 6 and 8 are 3 recurring digits. So multiplying both the sides by 1000. If you multiply the 1000, then you will get here 1000x is equals to 29,568 point. Again, 568 raised to bar. Okay. Now the subtract x is equals to 29.568 raised to bar from this equation. That is 1000x minus x is equals to 29,568.568 minus 29.568. 1000 minus x, you will get here 999x, and subtraction of this here, that is a 29,539. Okay, and hence x is equals to 29,539 upon 999, and hence the number 29.568 in P upon Q form can be written as 29,539 upon 999. Now next, 9.315 dash dash dash. Let suppose x is equals to 9.315 dash dash, and that can be written as 9.315 raised to bar. Here 3, 1 and 5 are 3 recurring digits. So multiplying both the sides by 1000, then you will get here 1000x is equals to 9315.315 raised to bar. Okay. Now the subtract x is equals to 9.315 raised to bar from this equation. Then you will get here 1000x minus x is equals to 9315.315 raised to bar minus 9.315 bar. If we subtract it, then you will get here 9306, and to the left hand side you will get here 999x, and hence x is equals to 9306 upon 999, and hence the answer is 9.315 dash dash, and that's equals to 9306 upon 999. Now next, 357.417 dash dash. Let x is equals to 357.417 dash dash, and that's equals to 357.417 raised to bar. Here 417 are three recurring digits, so multiplying both the sides by 1000, therefore 1000x is equals to 3,57,417.417 raised to bar. That is, if we multiplied this number by 1000, then move this decimal point to 3 digit, then you will get here 3,57,417 point. Again, the recurring number, that is a 417 raised to bar. Now next, subtract x is equals to 357.417 raised to bar from this equation. Then you will get here 1000x minus x is equals to 3,57,417.417 raised to bar minus 357.417 raised to bar. And after subtraction, you will get here 999x is equals to 3,57,060. Okay, and hence x is equals to 3,57,060 upon 999, and this is in the form P upon Q. Okay, now next, 30.219 raised to bar. Again, let x is equals to 30.219 raised to bar. Again here 2, 1 and 7 are three recurring digits. So multiplying both the sides by 1000, then you will get here 1000x is equals to 30,219.219 raised to bar. Again, subtract x is equals to 30.219 raised to bar from this equation. Then you will get here 1000x minus x to the left hand side, and for the right hand side 30,219.219 raised to bar minus 30.219 raised to bar, and after subtraction you will get here 999x is equals to 30,189, and hence x is equals to 30,189 upon 999, and this is the answer. Now next, write the following numbers in decimal form. Okay, now see this here. The first number is minus 5 by 7. It is written as in this manner. You can see this. The division I had explained in my previous practice set. Okay, and hence the answer is minus 5 by 7 is equals to minus 0.714285. These are the recurring, and hence it's raised to bar. हे सर्व डिव्हिजन तुम्ही बघू शकताय. Okay, next, again same thing is here. 9 upon 11, if we divide it, then again you will get here a recurring, that is a 0.818181. See, this is the division, and finally it is written as 9 upon 11 is equals to 0.81 raised to bar. Again, same type of the division, root 5. This is again big one. तुम्ही हे बघू शकताय कसल्या प्रकारे ते डिव्हिजन दिले. यापूर्वीच्या प्रॅक्टिस सेटमध्ये मी सर्व एक्सप्लेन केलेले आहेत. हाऊ टू फाइंड आउट the division of these root numbers, that is the irrational numbers. Okay, and hence it's written as root of 5 is equals to 2.2360679. It is non-terminating and non-recurring. Next, 121 upon 13. See this again here, division at this stage. Again the recurring starts. हे division बघू शकताय तुम्ही पुन्हा. Therefore 121 upon 13 is equals to 9.307692 raised to bar. Again these are the recurring numbers. And the last is very easy. That is a 29 upon 8. This is terminating division because the factors of 8 are 2 into 2 into 2. Okay. Therefore, the remainder is 0. Therefore, 29 upon 8 is equals to 3.625. Easy division आहे ते. Okay, 29 upon 8 is equals to 3.625. Okay. Now, in this way, we have completed this question. Now, next question. Show that 5 plus root 7 is an irrational number. Now, see this here. Let us assume that 5 plus root 7 is a rational number. Indirect proof, I have 5 plus root 7 is equals to p upon q, where q is not equals to 0. P and q are integers. Therefore, root 7 is equals to this 5 we will take to the right hand side. Then it will become p upon q minus 5. Now see this here. The right hand side here, p upon q minus 5. This is a rational number. And again, rational is equals to irrational. This is not possible. While the left hand side, that is a root 7, is an irrational number. This is contradictory. Therefore, our assumption that 5 plus root 7 is a rational number is wrong. And hence, 5 plus root 7 is an irrational number. Now next, write the following sets in the simplest form. First is 3 by 4 into root 8. Now see this here. 3 by 4 into root 8 can be written as 3 by 4 into, in root of this 8 can be written as 4 into 2. Now separate this, that is the 3 by 4 into root 4 into root 2. Root 4 means what? 2. Therefore 3 by 4 into 2 into root 2. Okay, again after simplification, you will get here 3 by 2 into root 2. Okay, and this is the simplified form. 3 by 2 into root 2. Next, minus 4 by 9 into root of 45. Now, root of 45 can be written as root 9 into root 5. And root 9 is 3. Therefore, minus 5 by 9 into 3 into root 5. And hence, after simplification, you will get here minus 5 by 3 into root 5. This is the answer. Minus 5 by 3 into root 5. This is the simplest form. Next, write the simplest form of the rationalizing factor for the given set. First example, root of 32. Now this root of 32 can be written as root of 16 into 2. Root of 16 is 4, 4 root 2. And what is the rationalizing factor of 4 root 2 is root 2. See this here. 4 root 2 into root 2. Then you will get here root 2 into root 2. Here is 2 into 4. That is equals to 8. And hence A rationalizing factor of root of 32 is root 2. Okay. Therefore, the simplest rationalizing factor is root 2. Next, root 50. Again, root 50 can be written as root of 25 into 2. Root of 25 is 5 into root 2. Again, if you multiplied 5 root 2 by root 2, then you will get rational number. Okay, that is a 5. Root 2 into root 2, you will get here 2. 5 into 2, 10, which is the rational. Okay, and hence the simplest rationalizing factor is root 2. Therefore, rationalizing factor of root 50 is a root 2. Next, root of 27. Root of 27 can be written as root of 9 into 3. That is a 3 root 3. Again here, if you multiplied 3 root 3 by root 3, then you will get rational number. Again here, root 3 into root 3. Here is a 3 into this 3. 3 into 3, you will get here 9, which is a rational number. 9 is rational number. And hence, the simplest rationalizing factor is root 3. Okay. Next. 3 by 5 into root 10. Again 3 by 5 into root 10. We have to multiply this number by root 10 so that we will get here a rational number. That is a 3 by 5. Root 10 into root 10. Here you will get here 10. And after simplification, you will get here 3 into 2. Okay. That is equals to 6. Therefore, here 6 is a rational number. Therefore, the simplest rationalizing factor is root 10. If we multiply this number by root 10, then you will get a rational number. Next, 3 root of 72. Now, 3 into root of 72 can be written as 3 into in root of 72 can be written as 36 into 2. Okay, again 3 root of 36 into root 2. Root of 36 means root of 36 is 6 into this root 2, that is a 6 root 2, and here 3 into 6 root 2 means what? 18 root 2, that is 3 into 6 means what? 18 into this root 2. If we again multiplied this number by root 2, then you will get a rational number. How it is? Here root 2 into root 2, you will get here 2. 18 into 2, you will get 36. And this is the rational numbers. Hence, the simplest rationalizing factor of 3 into root of 72 is root 2. Next, 4 into root of 11. Here is the root of 11 is a rationalizing factor because root of 11, this is the prime number, we cannot factorize it. Therefore, 4 into root of 11 into root of 11, you will get here 11. 4 into 11, you will get here 44, which is a rational number. And hence, the simplest rationalizing factor is root of 11. Now, question number 7. Simplify. 4 by 7 in root of 147 plus 3 by 8 in root of 192 minus 1 by 5 in root of 75. Now, see this here. That is 4 by 7. Root of 147 can be written as 49 into 3 plus 3 by 8. Root of 192 can be written as 64 into 3 minus 1 by 5. Root of 75 can be written as root of 25 into 3. Next, 4 by 7 is as it is. Root of 49 is 7. And next, here root 3 plus 3 by 8 as it is. Root of 64 is 8 into root 3 minus 1 by 5. Root of 25 is 5 into this root 3. Okay. Now next, again the simplification. Here 4 root 3 plus 3 root 3 minus root 3. Because here 7 7 get cancelled, 8 8 get cancelled and 5 5 get cancelled. Then what you will get here? 4 root 3. Next 3 root 3 and next minus root 3. 4 root 3 plus 3 root 3, that is a 7 root 3 minus 1 root 3, then you will get 6 root 3. Or you can take root 3 as a common, then in bracket you will get 4 plus 3 minus 1. 4 plus 3 7 minus 1, that is a 6, and hence 6 root 3 is the answer. Now next, simplify 5 root 3 plus 2 into root of 27 plus 1 by root 3. Now see this here, 5 root 3 plus 2 root of 27 plus 1 by root 3. Now 5 root 3, 2 root of 27. 27 can be written as 9 into 3 plus. Now rationalize the denominator here. That is a multiplied the numerator and the denominator of 1 upon root 3 by root 3 into root 3. That is 1 into root 3 into root 3. Then what you will get here? 5 root 3. Root of 9 is 3. That is a 2 into 3 into root 3 plus this root 3 into root 3. You will get here 3. Okay. And the next simplification, 5 root 3 plus 2 into 3. You will get here 6 root 3 plus root 3 upon 3. Okay. Next, 5 root 3 plus 6 root 3, you will get here 11 root 3 plus root 3 upon 3. Next, this 3 into 11, you will get 33 into root 3 plus this root 3 upon this whole divided by this 3. Now, 33 root 3 plus 1 root 3, then you will get 34 root 3 upon 3. And this is the answer, 34 root 3 upon 3. Now next, in root of 216 minus 5 root 6 plus in root of 294 minus 3 upon root 6. Now the solution, okay, a root of 216 can be written as root of 6 square into 6 minus 5 root 6 as it is. Root of 294 can be written as root of 6 into 49 minus 3 upon root 6. Multiply this number, that is a 3 by root 6, numerator and denominator by root 6. Okay, and therefore minus 3 by root 6 into root 6 upon root 6. And next, after simplification, what is the root of 6 square? Is a 6, and hence you will get here 6 root 6 minus 5 root 6. Root of 6 into 49. What is the root of 49? Is 7 root 6. Next, 3 into root 6 upon this root 6 into root 6 to the denominator, you will get here 6. Okay. Now the next, here 6 root 6 minus 5 root 6 plus 7 root 6. Okay. 3 root 6 upon 6 means what? Root 6 upon 2, and hence here root 6 upon 2. Now from all these terms, take root 6 as a common. Then what you will get in bracket? 6 minus 5 plus 7 minus 1 upon 2, bracket complete into root 6. Now 6 minus 5 means what you will get here? 1. 1 plus 7, 8. 8 minus 1 upon 2, bracket complete into root 6, and after simplification 8 into 2, 16 minus 1 upon 2 into root 6. That is a 15 upon 2 into root 6. And this is the answer. Now next, 4 root 12 minus root of 75 minus root of 48. Now here 4 in root of 12. Root 12 can be written as root of 4 into 3. Root of 75 can be written as root of 25 into 3. Root of 48 can be written as root of 16 into 3. Okay, next the root of 4 is 2. Therefore here 2 root 3. Root of 25 is 5, and hence here is a 5 root 3. Next, root of 16 is 4, and hence here 4 root 3. Okay, next simplification, 4 into 2, 8 root 3. Next, minus root 3. Next, 7 into 4, 28 root 3. Again, okay. Next, take root 3 as a common. Then in bracket you will get here 8 minus 5 minus 28, bracket complete into root 8, and after simplification you will get here minus 25 root 3, and hence the answer is minus 25 root 3. Now next, 2 root of 48 minus root of 75 minus 1 by root 3. Now root of 48 can be written as root of 16 into 3, that is a 2 in root of 16 into 3, minus root of 75, that is a root of 25 into 3. Now here 1 by root 3 multiplied numerator and the denominator by root 3. Then you will get here 1 into root 3 is root 3 into root 3, then 3. Next, root of 16 is 4, and hence root of 16 into 3 you will get here 4 root 3. Root of 25 into 3, then you will get here 5 root 3, minus, okay, 1 into root 3, here 3, root 3 into root 3 is 3, okay. Next, 4 into 2, you will get here 8 root 3 minus 5 root 3, then root 3 upon 3. See this here, 8 root 3 minus 5 root 3 minus root 3 upon 3. Take root 3 as a common. Then in bracket you will get here 8 minus 5 minus 1 by 3, bracket complete into root 3, and after simplification, that is multiplied this 3 by 8, then you will get here 24, 3 into 5, 15 minus 1 upon 3, or you may have the LCM, that is 24 minus 15 minus 1 upon 3, bracket complete into root 3, and after simplification this, that is a 24 minus 16, you will get here 8 upon 3 into root 3, and this is the answer, 8 by 3 into root 3. Next, rationalize the denominator 1 by root 5, 1 upon root 5, therefore here multiplied numerator and the denominator by root 5, that is 1 into root 5 is root 5, root 5 into root 5 is 5, okay, and hence the answer is 5 upon root 5. Next, 2 upon 3 root 7, here multiplied in numerator and the denominator by root 7, 2 into root 7 is 2 root 7. Next, this root 7 into root 7, then you will get here 7 into 3, that is a 3 into 7, then you will get here 21 to the denominator, and hence the answer is 2 root 7 upon 21, and in this way denominator is rationalized, okay, the answer is 2 root 7 upon 21. Next, 1 upon root 3 minus root 2. Now the conjugate pair for this root 3 minus root 2 is root 3 plus root 2. Now multiplied here numerator and denominator by root 3 plus root 2. That is 1 into root 3 plus root 2 is a root 3 plus root 2. Next here a minus b into a plus b. Then what you will get here? A square minus b square means what? Root 3 bracket square minus root 2 bracket square. Then to the denominator you will get 3 minus 2, and hence root 3 plus root 2 upon 3 minus 2, then you will get here to the denominator 1, and hence the answer is root 3 plus root 2, and in this way the denominator is a rationalized, and this is the answer, root 3 plus root 2. Next, now next, 1 upon 3 root 5 plus 2 root 2, the rationalizing factor is here. The conjugate of 3 root 5 plus 2 root 2 is 3 root 5 minus 2 root 2. Therefore, multiplied n and d by 3 root 5 minus 2 root 2. And next, 1 into 3 root 5 minus 2 root 2 is 3 root 5 minus 2 root 2. Next, again here a plus b, a minus b. Then here you will get here a square minus b square that is the square of 3 root 5 bracket square minus square of 2 root 2 bracket square. Okay. And next 3 root 5 minus 2 root 2. Now the square of 3 is a 9. Square of root 5 is 5. Therefore you will get here 9 into 5. Square of 2 is a 4 and square of root 2 is a 2. That is 4 into 2. And hence 3 root 5 minus 2 root 2. Next 45 minus 8. And hence you will get here 3 root 5 minus 2 root 2 upon 37. And in this way the denominator is a rationalized. Now next 12 upon 4 root 3 minus root 2. Now again multiplied the rationalizing factor of 4 root 3 minus root 2 to the numerator and the denominator. Therefore, the rationalizing factor is a 4 root 3 plus root 2 multiplied here numerator and the denominator. Then you will get to the numerator 12 in bracket 4 root 3 plus root 2. And what about the denominator? 4 root 3 minus root 2 into in next bracket 4 root 3 plus root 2. Then here you will get here 4 root 3 bracket square minus root 2 bracket square. Now the square of 4 is a 16, root 3 square is a 3, root 2 square is a 2. Okay. Next 16 into 3. Then you will get here 48 minus 2. 48 minus 2 is a 46 and hence you will get here to the numerator 12 in bracket 4 root 3 plus root 2 upon 46 and after simplification you will get here 6 in bracket 4 root 3 plus root 2 upon 23 and hence the answer is 6 in bracket 4 root 3 plus root 2 upon 23 and in this way the denominator is rationalized. Okay, and this is the answer. And we have completed the problem set 2. At the same time, the chapter number 2 is completed here. You will get all the videos if you click the I button of this video. Now we will see in the next video. Till then, goodbye.